Hi all of you. So I think all of you are eagerly waiting for this session, how to guess options in JEE Advanced. And dear students, these are 100% proven techniques. That means, I will be talking about those techniques which you can use, and I will tell you the rationale behind what I am going to say. So welcome all of you for this amazing session. I'm your master teacher in physics, Prateek Garg. So guys, today's session, let me quickly tell you for whom this session is going to be very beneficial. See, if you have, if your basics are in place, that means you have a basic understanding of physics, but you struggle in advanced level questions. Okay, but you struggle in advanced level questions, then you should definitely see this session, because I'm sure that if you combine physics, chemistry and mathematics, then you will be able to increase your marks in JEE Advanced at least by 20 or 25 marks. I can safely assume that if you follow today what I'm going to tell you, right? Secondly, if you even if you have studied very well at JEE Advanced level, so towards the last 30-35 seconds are left and time is about to get over. Okay, time is about to get over, 30-35 seconds are left. Then also you can use these techniques. Suppose you are on a single choice question, then you can use these techniques, okay, to solve the question just smartly, okay, without much physics. Just basics should be in place, okay, just basic knowledge of physics should be there. And you can see I have taken almost all the questions from JEE, as most of the questions are JEE Advanced questions only. So they are not made by me, they are JEE Advanced questions itself, and you will see that we will do smart things. Okay, we will think rationally. I'm not going to apply much physics, just a basic knowledge of physics will be useful. Okay, so without wasting much time, let us start the session. So keenly observe, guys, what I'm going to tell you. So before just a second. Yeah, so before I tell you one, before we go into questions, before we go into JEE questions, let me tell you one important one statistics. Okay, if you talk about single option correct of JEE Advanced, see, JEE Advanced pattern changes every year. Okay, JEE Advanced pattern changes every year. If you talk about those questions which have single option correct with negative marking, so generally speaking, what is the marking scheme of such questions? So generally speaking, the marking scheme is +3 -1. Okay, generally speaking, marking scheme is +3 -1. Why do you think this kind of marking scheme is kept? The reason is that generally speaking, there are 4 options in a single option correct. Okay, I'm talking about SCQs. Right. So I'm talking about SCQs, and you have this type of marking scheme, generally speaking, +3 -1 in JEE Advanced. In JEE Mains you have +4 -1, but in JEE Advanced you have +3 -1. So option A, option B, option C, option D. Okay. Now, so if you are making a random guess, okay, let's talk about the random guess. Okay, you don't know anything, you have just you have not studied anything for 2 years. Okay, you just go and take a wild guess out of these 4 options. So let us say if you do those things in 12 questions, okay, so chances are, what does probability say? The chances are that out of 12 questions, 3 questions you are going to get right, 25% correct chances. I'm not saying that you would be lucky, and I'm not saying you would be unlucky. Okay, so on a fair day, you can say that 3 questions will be correct and 9 questions will be wrong, right? So how much marks you will end up getting? You will end up getting 0 marks, because if you make 3 correct out of 12 questions, I am saying, suppose you have got 12 questions. Okay, so if you get 3 correct and 9 wrong, okay, 9 wrong. So for 3, because out of 12 questions, 25% means basically 3 questions correct, and 75% wrong means 9 questions wrong. Aryan, I will be telling you dimension. Iske alawa, apart from that, I will also tell you many more fundas. So just keep on looking today's session. Dimension is there, but apart from that, many other things also coming. So 3 questions correct and 9 questions wrong. So how much this will give you? This will give you 3 9 marks. But since you have got 9 wrong also, so this is becoming -9. So net marks comes out to be 0. So this happens if we can say if you have got you are doing wild guessing. You are doing wild guessing. Okay. Now What happens if you have chosen one option to be definitely wrong? That means you have to guess amongst the three options. Now, if you are sure that suppose you are saying that option A is definitely wrong, definitely you have, like, for sure you have ruled out that option D cannot be correct. Then out of three options you have to take a wild guess. Out of three options you have to take a wild guess. Then what is the chance that you are going to get how many marks you will end up getting on a fair day? Okay, on a fair day, how many marks you will end up getting? So in that case you can say out of 12 questions, 1/3 will be right. So in that case you can say out of 12 questions, 1/3, that means 4 questions you will get it right and 8 questions you will get wrong. Okay, so 4 3s are 12 and 8 wrong means -8. So that means you will end up getting 4 marks. In this case you will end up getting 4 marks, right? What happens if you have two options? That means if you are definitely sure that two options has to be wrong, if you have said that two options are definitely wrong, suppose you have ruled out that C and D cannot be correct, C and D is definitely wrong. Okay, so in that case what will be your answer? Think carefully. So how much marks you will get in that case? So out of 12 questions, 6 will be right and 6 will be wrong. So if you see 6 questions correct, so how much you will end up getting? 18 marks, and 6 wrong, you will get -6. So how much you end up getting? 12 marks. Now dear friends, think. Now this is the good thing. This is the strategy. This is the good thing. Basically what I can tell you is that out of 12 questions, if you have ruled out 2 options definitely, then taking a guess is a logical option amongst the remaining 2. So this is my first point. If you have ruled out 2 options definitely, that means with absolute surety, if you have rejected 2 options out of the 4, okay, then it's a logical thing to take a guess amongst the remaining 2, because even if you get half of them right or half of them wrong, then also you end up getting 12 marks. You have to be really unlucky. You have to be really, your karma should be really wrong. If you want to go into negative, like if you will go into negative, but if you are lucky, then you will get up very good marks. If you are unlucky, very unlucky, then only you will get 0. But if you have rejected 2 options with absolute surety, then it's a logical thing to take a guess, my friends. So I hope you are able to understand that if out of 4 options you have rejected 2 options with absolute surety in an SQ course, okay, so it's a logical thing to take a guess out of remaining 2 options. Okay, the chances are that if you combined all the questions, all such questions in which you have taken guess out of 2 options, then you will end up getting positive marks. These are high chances. Now guys, let us see one thing. I have written down some points and I will apply. I have written down some points. I will apply. Basically, I will tell you what these thing means. Okay, what these thing means. So basically, see, check for extreme values like t equals to 0 or t tending to infinity. That means we will check for extreme values. That means t equals to 0 and t tending, like, what I will tell you what does that mean. That means, in the questions when I will do, so you will understand that what do we mean by checking the extreme values. Okay, use of dimensional analysis, all of you know that what happens when we use dimensional analysis, right? Range of the answers, we will see that in what range answers can lie. Just note down the points. When I will apply these points, you will understand that what do we mean by these points. Options that are negative or can be made negative, whereas answer cannot be negative. That means suppose there is an option which can be made negative. Okay, what do we mean by making a negative? I will tell you when we do questions. Just I am telling you the points right now. When we will apply a question, when we will apply these points to the questions, then you will understand. So those options which can be made negative, but we are sure that answer cannot be negative. So those options can never be our answer. So I will tell you all these things. Okay, whether the value will increase or decrease after the change. What does this mean? This means that, I think some of you are saying that mic is not adjusted. I think it's fine now. So basically what I'm saying is, suppose we do some change in the question, that means some values are being changed, and we will see whether the answer should have increased or decreased. So we will apply these things. Use of basic knowledge of physics. I told you that you should have basic knowledge of physics. That is bare minimum. Never leave a question in which there is no negative marking. Of course, if there is a question which does not have negative marking, you should never ever leave that question. Also in integer type, I have seen many students not making a guess if there is no negative marking. Guys, if there is no negative marking, make a wild guess in an integer question. You never know how much basically how much lucky you might be. You might get one answer correct, and one answer correct means 3-4 marks, which can propel your ranks by thousands. So always take a guess when it's no negative marking. And now let us see some of the questions which have been asked in JEE, and we will apply these techniques going ahead. So you can see the first question. Now this question was asked in JEE Advanced 2001. The question says that you can see that there is a this is a pulley of mass small m. I will be applying just the shortcut techniques. Okay, I will not do this by proper physics. So you see, although many of these questions can be done very fast by the normal method as well. So this pulley is of mass small m, and this block is of capital M. We have to find the force applied by the clamp on the pulley. That means the force applied by here. Okay. Now think very carefully. What happens if the pulley, assume small m 0. Assume small m 0. So if pulley is massless, then what will be the force? Then tension here will be anyway mg. Okay, tension here will be anyway mg. So that means here mg will be the tension, and here mg will be the tension, right? So what will be the force? This is very simple. The string is applying root to mg. You can see the string is applying root to mg. If we assume m equals to 0. Hence we can say that if small m equals to 0, then the force applied by the string on the pulley should be root to mg. Therefore, clamp should also apply the equal amount of force. Therefore, we can say that if you put small m 0, answer should be root to mg. Guys, if you put small m 0, then the answer should be root to mg. Okay, so we put capital mg. So answer should be in this case root to capital mg, right? If we put small m 0, answer should be root to capital mg. Option B is rejected because in this there is no like we are getting root to small mg. So option B cannot be our answer. Okay, option B cannot be our answer. If you check option C, you put small m 0. So this is coming root mg. This is coming mg, not root mg. This is coming mg. So this is also wrong. You can see option C cannot be correct. Option A and option D are still the possibility, because option A still says root to mg, and option D, if you put small m 0 here, option D becomes root to mg, right? So how to reject between option A and D? Now put capital M 0. Now put capital M equals to 0. Okay. So if you put capital M equals to 0, so what will be the value of the, so that means there is no block. There is no block. Here string is basically slack. Tension has become 0. So what is the value of the force on the pulley? Just small mg by gravity. Okay, this is the force by the gravity. Okay. String is not going to apply any force because the string has become slack. Right. So the clamp is also going to apply the force of small mg. I hope you understood the logic. If there is no capital M, that means string has become slack. That means pulley will have a force of small mg. So in that case, clamp will apply equal and opposite force. So we can say that answer should become small mg if capital M is 0. So you can see in this option it does not happen. You cannot put, if you put capital M 0, then this answer becomes 0. So this is not possible. Okay. So here if you put capital M equals to 0, this answer becomes small mg, and only option left is option D. So you can see option D is correct. I hope you would have understood, although you can do this question very fast by the normal method as well, but I have just told you a simple technique. I checked small m equals to 0 and I checked capital M equals to 0 and I found out my answer. Okay, this is a JEE Advanced question 2001. Let's move to the next question, guys. Let's move to the next question. See this question. A highly rigid cubical block. Okay, this is a very nice question which came in JEE 1992 Advanced. A highly rigid cubical block A of mass m and side length L is rigidly fixed onto another cubical block B of same dimensions and of low modulus of rigidity eta, such that lower face of A completely covers the upper face of B. So what is happening here, guys? Basically this is a block B. Okay, this is a block B. Okay, and on top of it you have placed another block, let us say of this type A. Right, this is A. Okay, now so this is the situation. This is of side length L. Block A is of side length L and the mass is M. Right, now small force is applied perpendicular to one side. So basically this type of force is being applied here. Right, after the force is withdrawn, we have to find the time period of the oscillations. So you know, by the spring block system, the time period has this type of dimensions, 2 pi root of m by k. Okay, this type of dimensions time period has. Okay, 2 pi root of m by k, right? M is mass and k is the spring constant. So what is the dimension of k? What is the dimension of k? Dimension of k you can say is force upon length. That means this dimension of force divided by dimension of length. So this is the dimension of k. Now if you go to the options, you can see all have different dimensions. When you see that in the options there are the terms with different dimensions, then you should always think of dimension analysis. In the previous question, all the terms have the same dimension, ABCD. This had a dimension of force, this had a dimension of force, this had a dimension of force, this also had a dimension of force. So dimension analysis would not have worked here. But I told you a different technique to eliminate the options here. But if you go to this question, here all the terms have different dimensions. First option is m into eta into L. Second is m into eta by L. Third is m by eta L. And fourth is ml by eta. So all have different options. So how should we go about this question? Of course, dimensional analysis will be the very good technique over here. Okay. So what should we do over here? See, let's just quickly find out the dimension of eta. Okay, let's just quickly find out the dimension of eta. So dimension eta is what? Eta is the modulus of rigidity, right? Eta is the modulus of rigidity. So what we can say, that dimension of modulus of rigidity will be that of pressure, right? Dimension of modulus of rigidity will be that of pressure. That means will be force upon area. So dimension of eta will be equals to force upon area. This will be the dimension of eta, right? So that means this will be the dimension of force upon dimension of area is L square, you know. So that means if you think carefully, we can say that the k has a dimension of force per unit length. K has a dimension of force per unit length, okay, and eta has a dimension of F by L square. So basically, if you check option A, okay, so we can write this as dimension of k, okay, upon dimension of length, right? So because force upon length I have written as dimension of k, and one length will be remaining. So now you go to option A. If you go to the option A, so what is happening here? 2 pi into m eta L. So if you put the dimension of eta, what will this become? M into eta ka dimension is root of k upon, let me rub this, just hold on. So I'll erase this part. We have already concluded that dimension of eta is k by L, okay? So let me write this. So dimension of eta comes out to be k by L. So if you put the dimension of eta here, that is root of k by root of L, okay, multiplied by L. So this term is becoming m into k, whereas we want m by k. So option A cannot be correct. Okay, this is gone. If you check option B, so this is m into k by L, and one L is also remaining in the denominator. So this is becoming m into k by L square, whereas we want m by k. So option B is also wrong. Okay. If you check option C, so here you can see that m by eta, dimension of eta is root of k by L, and one L is also present here. So you can see this cancels out. So we get m by k. This is exactly what we wanted. So option C can be our one possibility. I think here we have written A. So option C can be our answer, and of course option D will have another dimension. So you can see only option that matches is option C. Now this question, if you try to do by proper physics, then I can tell you this is a nice question. You will take some amount of time, and most of you might not be able to do this question in the exam. The reason is because this was slightly a good question. Okay, so I hope you understood how dimensional analysis can be helpful. Let us move to the next question, guys. This is again a very nice question. Okay, this came in JEE Mains 2014. If you look, what is happening over here? This is a circular tube in a vertical plane. two liquids which do not mix are of density d1 and d2. So the liquids are of density d1, this is of density d1, and another liquid is of density d2, are filled in the tube. So you can see the densities which are already filled in the tube. Each liquid subtends an angle of 90 degree at the center. So both the liquids subtend an angle of 90 degree at the center, and that means this, what angle is 90? If you join this line, okay, and you join this line, so this angle total is 90. Okay, similarly if you join this line, okay, and you join this line, so this angle is also 90. This is what they are saying. Okay, think this was a very nice question, guys, but if you think rationally, we will be able to solve this question very easily. Just listen to me what I'm going to tell you. Okay, we have to find the ratio of d1 by d2, and alpha is the angle made by the interface. This is the interface. So alpha is the angle made by the interface with the vertical. So this is the vertical line, and alpha is this angle is alpha. They are calling this angle as alpha. Okay. Imagine what happens if I assume d1 equals to d2. Imagine if I assume d1 equals to d2. Okay. So if d1 equals to d2, that means both these liquids are of same density, right? That means I am saying both these liquids are of same density, right? Then alpha will become 0 because both the liquids will be just occupying this type of thing. From here till here, this will be liquid d1, okay, and from here to here, it will be liquid d2. If d1 and d2 are of equal density, then whole thing will be just in the bottom half of the tube. I hope you are able to understand this. If d1 equals to d2, then both these things will just come in the bottom half of this tube. Then what should be the value of alpha? Tell me, what should be the value of alpha? So in this case, alpha should come out to be 0. That, what is the implication we get? Alpha comes out to be 0. So if d1 equals to d2, then alpha should have been 0, right? So check. If you put alpha 0 here, so basically d1 by d2 is becoming 1. So that means this ratio is becoming 1. So d1 by d2 is becoming 1. So option A seems possible, right? Just a second. Yeah, so d1 by d2 is becoming 1. So option A seems possible if we put alpha equals to 0. So option A is not rejected. If you put alpha 0 in the option B, so what do we get? Denominator becomes 1 minus 1, so that means it becomes infinite. So whereas we wanted d1 by d2 to be 1, so if you assume d1 equals to d2, then that means alpha should be 0. That means the ratio should be 1. But option B is definitely not giving you that. Option B is giving you infinite value. So option B cannot be your answer. This is wrong. This is rejected. If you go to option C, again if you put alpha 0, the option C converges to 1. That means option C is still a possibility. Option C is still a possibility. If you go to option D and you put alpha 0, so again option D becomes infinite because denominator is 1 minus cos 0. So that will become denominator will become 0. So option D cannot be your answer. So we have very intelligently rejected option B and D. Okay. Now either you can take a guess or what you can do, you can still apply one more logic. Okay. Imagine what happens if I assume d2 to be 0. Imagine. That means I am assuming this liquid to be of very low density. Like feel what I am saying. Suppose d1 is very low. d1 is very high. I am saying d1 is much greater than d2. I am saying what happens if d1 is much greater than d2. Then where will this ratio tend to? d1 by d2 will tend to infinite, right? d1 by d2 will tend to infinite. And what will happen here? If d1 is very heavy and d2 is almost negligible, then you can say that this liquid will not be, it's like there is nothing here. d1 will not feel the presence of d2. I hope you are able to understand. d1 will not feel the presence of d2. It's like air is present here. So this liquid will be symmetrically placed. That means d1 will be like this. Okay, d1 will be like this, and d2 will not be able to push it down because d2 is very light. So d1 will be like this, and this total angle was 90 degree. So that means alpha will be 45. I hope you are understanding, guys. So in this case, if we assume d1 to be very high than very large than d2, then alpha will come out to be 45. Now put here amongst option A and C, if you put alpha as 45, so option A does not go to infinity, whereas we want option d1 by d2 to go to infinity. So this option becomes wrong, because if you put alpha 45, option A is not going to infinity. Whereas if you put alpha equals to 45 here, option C goes to infinity, because denominator becomes 0. And hence we can say that option C should be correct. I hope guys you would have understood an amazing technique by which you could have solved this question very fast. Okay. I am taking time here because I am trying to explain, but if you think this on your own in exam, you will not be able to write. Otherwise, you will have to write a long equation in this in order to solve the question. But over here, you can straight away say that this question we can solve just by intelligent work. I hope you would have understood. Let's move to the next question. See this question. Again, this question, if you, without even reading the question, if you just look at the options, then you will be able to understand that here the dimensions are different. Okay, here the dimensions are different. Here we are getting mk square r square, here mk square r square, here mk to the power 4 and all those things. So this question we will try to do by dimensions. Okay, so what is happening over here? A particle of mass m is moving in a circular path of constant radius r such that centripetal acceleration AC is varying with time t. So value of, I am not going to do this question by proper physics. I'll just quickly tell you by dimensions. Okay, so value of acceleration is given by this. So that means they are saying acceleration is nothing but this is given by k square, okay, r in t square. Okay, so multiply this by m, so this becomes force. This becomes force. And you know what is the dimension of force? Dimension of force is, so basically this becomes the dimension of force. So from here you can say that dimension of k square comes out to be, r t square into m. So we can say that dimension of k square will be dimension of r, like this term will be this term. Dimension of force divided by dimension of this term is going to give you the dimension of k square, right? Dimension of k square kaise aayega? How will you get dimension of k square? Dimension of force divided by dimension of r t square into m. Okay, now we want to find the power. That means option A, B, D, so we can say that power will not be 0, because the speed of this particle is increasing. If the centripetal acceleration you can see is a function of time, that means centripetal acceleration is increasing, right? Centripetal acceleration is increasing. Now if centripetal acceleration is increasing, that means speed is increasing, because centripetal acceleration is also v square by r, basic knowledge of physics, right? So that means speed is increasing. That means power cannot be 0, because if speed is increasing, how can power be 0? That means it was getting kinetic energy. So option D is definitely wrong. Okay, now if you go and check the dimension of option A, so we want dimension of power. Okay, we want dimension of power, and power is force into velocity. So if you check option A, let me check option A. So this is 2 pi m k square r square. So 2 pi does not have any dimension. So m is here. Dimension of k square I am putting from here. Dimension of this was the dimension of k square. So we will write here force. Okay, we will write here force, dimension of force. Let me rub this. Okay, I'll have to read this. So force upon r t square m. Okay, this is the dimension of the force. Sorry, this is dimension of k square, and I'll also have to multiply by r square. So I will also have to multiply by r square. So this is the term that I get. So you can see that r square, it will not get cancelled. So 1 will, this was 2 here. So this 2 will get cancelled from here, and m will get cancelled from here. So this becomes force into r upon t square. You can see this becomes force into r upon t square, which is not velocity. It should become force into velocity. Power is force into velocity. So it is becoming force into r upon t square. It is not velocity. If you go and check option B, let's check option B. Option B is m k square r square t square. So option B is m k square r square into t. So put the dimensions of k square. So what is k square? Dimension of force. Dimension of force. Okay, divide by r t square m. R t square m. Okay, and you will have to multiply this by r square into t. So you can see m gets cancelled. Okay, then 1 r gets cancelled and 1 t gets cancelled. What are we left with? R by t. You can see we are left with r by t. So distance upon time, it is velocity. So that means this becomes dimension of force multiplied by dimension of velocity. Dimension of velocity. right? Which is what power is. So I think you have understood that option B gives you the dimension of velocity. Option B is correct. In this question, if you check option C, also, this will also be the this will also give you the correct dimensions, but you can see that out of B and C you can take a guess, as I told you, because we have definitely rejected option A and D. With absolute surety we have rejected option A and D. So out of two options you could have taken a genuine educated guess, and B and C are set. If you check option dimensions of option C, it will also satisfy that of power. But as I can tell you, out of B and C you could have taken a guess. Okay, let's move to the next question. Let's see this question again. A very beautiful technique. If you go to the dimensions, then it will not work out in this case. Dimensional analysis will not work out in this case. Why? Because if you can see, all the options have same dimensions, 2 pi root of L by G. So dimensional analysis is not going to help you in this particular question, right? But let us see how we could have rejected the options intelligently. Read the question once. The period of oscillation of a simple pendulum of length L suspended from a roof of vehicle which moves without friction down the inclined plane of inclination alpha. So what is happening? This is an inclined plane. Okay, this is of inclination alpha. We have one vehicle like this. It is going down the plane. Okay, and it's basically we can say that the simple pendulum is over here. Now, what is the time period of this? Imagine if alpha is 0. What happens? If we assume alpha to be 0. So if alpha is 0, then this becomes a normal ground. Inclined plane becomes a normal ground. So vehicle will become like this. So this becomes a normal pendulum. So if alpha is 0, we can say that this becomes a normal pendulum. Time period would become 2 pi root of L by G, right? So if you put alpha as 0, in which option you get 2 pi root of L by G? Put alpha 0 in option A, you get 2 pi root of L by G. So option A might be a possibility. We will not reject option A. Put alpha 0 here. Option B is becoming infinite. So this is wrong. Definitely this is wrong. Put alpha 0 here. So again option C is becoming infinite. So again this is wrong. And option D is saying 2 pi L by G. That means it is just equals to this now. So as of now we will not reject D. Okay. As of now we will not reject D. Okay. What happens if alpha becomes 90? Think carefully. So if you understand, we are checking extreme values. So remember, I had written one point that check for extreme values, right? Now if alpha becomes 90 degree, what happens? This inclined plane has become vertical sort of. Think logically. So basically I'll draw with the red color. So you can see that this inclined plane has become sort of vertical. So that means this vehicle will be in a free fall. Right? I hope you are understanding. So if this vehicle is in a free fall, then we can say that G has become 0. G effective has become 0, because if this vehicle is in a free fall, it will not feel gravity, right? So if it will not feel gravity, it will not oscillate only. It will not oscillate. Its time period should become infinity. Hence, if alpha we assume 90, then T should go to infinity. So if you put, so this is not happening in option D. But if you put alpha 90 here, this option goes to infinity. Hence, option A should be the correct answer. Guys, I hope you are understanding. We are just applying some smart, intelligent, basic physics knowledge. Not very high-fi physics. Okay, just basic things that we, like mains level physics, right? And we are able to do all these are advanced questions, 2000 JEE advanced question this is, right? Let us see the next question. This is a very, very nice question that came in 2010. You can see it's a very, very beautiful question. So if you read, again, this had to be done by dimensional analysis. If you just look at the options, all the options have different dimensions. All the options had different dimensions. So we wanted the value of the force. So we just have to check those options which has a dimension of force. Okay, so here actually the question is that the question will be actually solved using electrostatic pressure, but here we have to just find the value of the force. So if you look at the options, they have different dimensions. So you know, sigma is the charge density here, r is the radius, and epsilon naught, you know, is the permittivity of the free space, right? So how could you have guessed using dimensional analysis? Very simple. See, we know that force is nothing but q into electric field, right? So dimension of force will be is equals to dimension of q into electric field. Make sense, right? Now what can you write about dimension of q? That will be sigma into dimension of area, right? Sigma into dimension of area. And you know that electric field, now here epsilon naught is coming. You can see in all the options epsilon naught is coming. So you know that the field of sheet, infinite sheet, is sigma by 2 epsilon naught. Basic knowledge of physics. Sigma by 2 epsilon naught is the electrostatic field in front of infinite sheet. So you can say that electric field will have the same dimension as that of sigma by 2 epsilon naught. 2 anyway, which will not have any dimension. So you can see this becomes sigma square into area upon epsilon naught. Dimensionally, this will be the same thing. Now area is nothing but you can see r square. Area has a dimension of r square. So you can see sigma square into r square upon epsilon naught. So very easily we have reached our answer, option A. If you try to do this question using proper physics, then it's a nice question. You will have to use the concept of electrostatic pressure, but this was, I think, JEE intentionally gave you to solve this question using dimensional analysis itself, right? I hope you would have understood, guys. It's a very, very nice technique, dimensional analysis. So I have told you some techniques apart from dimensional analysis as well. Let's see more questions. Okay, see this again, very nice question which came in 1983, the first time India won the World Cup. So that time, a thin circular ring of mass m and radius r is rotating about its axis. So basically what is happening is a very easy question, by the way. Many of you will be able to solve this, but idea is to do this question intelligently. I mean, this is a very easy question. Many of you can solve this with basic physics. Very, very easy question. So this is rotating with angular velocity omega and mass of this ring is capital M. The radius is r. Okay. If you check the dimensions, then all the terms have same dimensions. I think this by mistake it has become A. So this will be B, this will be C, and this will be D. Okay. So basically here the ring has a mass of capital M. Okay. Now you are attaching two small masses over here. So that means one small m is attached here and another small m is attached here. Okay. What will be the new angular velocity of the ring? I hope you know that this can be solved very easily by angular momentum conservation. But if you think carefully, when you attach a mass, it will slow down. Obviously, if you are attaching a mass, you are making it heavier, so it will slow down. That means omega should decrease, right? If you are attaching a mass, omega should decrease. That means final answer should be less than the original omega, right? Final answer should be less than the original omega. Okay. Now if you see the fraction here, capital M by M plus 1, so this is less than 1. You can see capital M upon M plus M, okay, into omega. So this fraction is less than 1. Hence this answer is less than omega. So this is a possibility. Okay. If you check option B also, so this value is less than 1. So it is still a possibility. If you check this value, this is also less than 1. Okay, this is still a possibility. But if you check this value, so this value is greater than 1. Capital M plus 2m by capital M, this value is greater than 1. So option D is saying that the final angular velocity has become more than initial angular velocity. So this is not possible. If you attach two particles, it will slow down. So option D is definitely wrong. Option D is definitely wrong. Okay. Now let me tell you another logic. If you put, suppose if you put small m as equals to, let's say 3m by 4, let us say this value. Why am I putting this value? Because if you see, option B will become negative. Omega will become negative for option B. Option A and C, it will be positive, but option B, it will become negative. Okay, this is not possible. Omega cannot become negative. That means the disk will rotate in the opposite sense, but that does not happen. If disk is rotating like this and you attach two particles, it will keep on rotating in this same sense with some reduced angular velocity. So I am using this logic. It will keep on rotating in the same sense with reduced angular velocity. It will not go in the opposite direction, right? So that means this option is saying that, option B is saying that if you, I'm saying that let's assume that small m equals to, like, any value of small m greater than m by 2. Any value of small m greater than capital M by 2. So in that case, you are saying that option B will become negative, which is not allowed. Option B cannot be, it's not possible. Amongst option A and C, you will have to take a guess again. So we have removed option B and D by absolute surety. With absolute surety, we are sure that option B and D cannot be correct. Out of A and C, you can take a guess. Although this question is very easy, I know that most of you can solve this just by proper physics, but I was just telling you that how can you solve this question just by intelligent work. So by intelligent work, we have rejected option B and D with just basic knowledge of physics, not hi-fi thinking. Okay, let's see the next question. Again, this is a nice question. If you try to do this formally, you might get stuck. You might not be able to solve this question if you have not done enough practice. But let us see can we think rationally. Let I be the moment of inertia of a square plate. So basically this is a square plate. Okay, think of this as a square plate. Okay, so we have this axis, let us say this axis, and I is the moment of inertia about this axis. Okay, there is another axis that makes an angle. So this axis is AB. So this is AB. Okay, this is AB. CD is another axis that makes an angle theta with the AB and passes through the center of the plate. So how does CD look like? So you can see that CD will look like somewhat, let's say, this type of axis. So this is CD. Okay, and this angle is theta. So what will be the moment of inertia about CD? Many students, when I ask this question, they have a tendency to write I cos square theta. Many students, they have the tendency to write I cos square theta. If you think logically, we can do this question very easily by physics also, but right now I am not going to discuss physics. Let us think carefully. If I assume theta 0, then CD and AB will coincide. Okay, if theta is 0, think, if theta is 0, then CD and AB will coincide. CD is nothing but AB. Okay, then we can say moment of inertia about this axis, let us say I dash. So I dash will be is equals to I only. So that means if theta is 0, the answer should be I. If theta is 0, the answer should be I. Now if you go to option B, put theta 0 here, this becomes 0. So option B is wrong. If you go to option C, put theta 0, so it becomes I. That means option C is still a possibility. If you put theta 0 in option D, it becomes I. So it is still a possibility. So out of 4 options, we have rejected 1. Okay. I hope you have understood till here. Okay. Now put theta 90. Now put theta equals to 90 degrees. So if you think carefully, what happens when theta becomes 90? Let me show you. The axis will look like this type. It would become horizontal. This type of axis. You can see CD will become horizontal. If you put theta 90, it will become horizontal. Now it is very easy to see that the square plate will have equal moment of inertia on the blue axis and the green axis. It is very easy to see because it is symmetrical with respect to these two axes. So if you think the moment of inertia is I about this axis, the moment of inertia should also be I about this axis. Very easy because it is just, it's a square, it's symmetric. So I dash will be again I. So again in this case we are getting I dash is equals to I, right? So put theta 90. So if you put theta 90 here, this becomes 0, not possible. If you put theta 90 here, this becomes cos square 45, so I by 2, not possible. Hence only option A is left. So we have done the question very intelligently, without any physics, just basic thing. I hope you have understood, guys. Very intelligently we have solved this question, right? Let us move to the next question. Again, if you see what is happening here, a cubical block of side L rests on a rough horizontal surface of coefficient of friction mu. A force F is being applied at the top. If the friction is sufficient enough so that block does not slide does not slide before toppling, then minimum value of force required to topple. So in this question we have to find the minimum value of the force required to topple. The question is very easy. Again, we can solve this by one equation. But again, if I am not using physics, I am just being intelligent and smart. So First option is definitely wrong. It says that if you apply even a small force, then also it will topple. Infinitesimal means just a small force and it topples. It doesn't happen. Take a cold drink water and apply very small force. Will it topple? No, it will not topple. So basically, it for toppling you will have to apply a thoda slightly ज़्यादा force, slightly large force. So of course this is wrong, right? Option A is definitely wrong. Okay. Now, if I put mu greater than 1, assume mu greater than 1. Now some of the students might feel that mu greater than 1 is not possible, but actually it is not the case. Actually it is not right. Mu greater than 1 is of course possible. Okay, mu greater than 1 is of course possible. So if you put mu greater than 1, then you can see option D is becoming negative. Option D is becoming negative. How can force be negative here? You are applying a force. So of course your answer cannot be negative. It will have some value. It is asking what is the minimum force that is required to topple the block. So it will have some value, right? I hope you're understanding this. So basically we can say that this option is definitely wrong. Again, out of B and C you can take a just wild guess, because we have definitely rejected option A and D. So out of these two options, B and C, you can take a guess. Although this question was very simple anyway, you could have solved this without much hassles if you write the equation. But again, my job right now is to not write the equation but do this question very smartly. So we have rejected option A and D and you can take a guess now. Now let's do this question. This question came in JEE 2009. Think carefully what is happening here. This block is oscillating with amplitude A. This block is oscillating with amplitude A. What is the amplitude of point P? Again, the question is not difficult, but what we have to find? We have to find the amplitude of point A. I will tell you beautiful logic. Think very, very rationally. Think very, very carefully. Okay, what I am saying. Suppose K1 is very large. Okay, suppose K1 is very large. Think what I am saying. If K1 is tending to infinity, that means this spring is becoming very rigid. This spring is becoming very rigid. I hope you're understanding. This spring will become very rigid. This will not even oscillate. K1 is very high, so you can see this spring oscillation will not happen. That means this spring can be treated like a rod. So this point P will not oscillate. Point P will always be at rest. Understanding? Point P will always be at rest. If K1 is very large, if K1 tends to infinity, this spring will not oscillate. This has become rod. This has become very rigid rod. So K1 will not oscillate. So that means P cannot move. So amplitude of P should be 0. So in that case, answer should be 0, right? Let us see in which option this happens. So if you put K1 infinity, this option A becomes infinity. So this is not possible. Option A is simply not possible. If you put K1, as infinity here, option B is becoming 0. So that means B is a possibility. That means B is a possibility. If you put, if you check option C is K1 upon K1 plus K2 into A. This is what option C is. So if you put K1 as infinity, so you can see that this fraction will tend to 1, because this will be a very high value, this will also be a very high value. So this value is tending to 1. Okay, this value is tending to 1. So again, this is wrong, because we don't want this to tend to A, we want it to tend to 0. So, sorry, yeah, 0. So that means this option is again wrong. Option D is again wrong. Okay, so option C is again wrong. Now check option D. So if you put K1 as infinity, then you can see K2 upon K2 plus K1. Look at this option, K2 by K2 plus K1. This will become 0. So option D is still a possibility. So out of A, B, C, D, we have rejected A and C. The logic is written here. K1 tending to infinity, answer should tend to 0. Okay, answer should tend to 0. This is the first logic. Now what happens if K2 tends to infinity? If K2 is infinity. Okay, so let's check. If K2 is infinity, that means this spring will not oscillate. That means you can treat it like a single object, because the distance is not moving. This K2 is not moving. You can treat it like a single object. So whatever M moves, P will also move. This distance will not change, because this oscillation has become impossible now. K2 has become very large. So this oscillation is not possible. So whatever M moves, P will also move. So in that case, answer will become A, because M moves A. So P will also move A. I hope guys you are understanding what I am telling you. This is a very smart way of doing this question. So in this case, if K2 is infinity, answer should be A. So if you look at option B and put k to infinity, it does not become A. So option B is also wrong. If you check option D and put k to infinity, so you can see that option D will tend to A, because k2 by k2 plus k1 will become 1. So option D is correct. We have rejected A, B, C with absolute surety. So only option left was option D. I hope you are understanding what I am telling you. Very, very fast way of doing questions. Okay, let's see this question. Here we have been asked fraction. We have been asked the ratio of L1 by L1 plus L2. And there are two rods, aluminium and steel. The alpha of aluminium is alpha A and alpha of steel is alpha S. Okay, alpha of aluminium is alpha A and alpha of steel is alpha S. Okay, and we have been asked the value of L1 upon L1 plus L2. What is L1? L1 is the length of aluminium rod. What is L2? L2 is the length of steel rod. So we have to talk about this ratio. Guys, it is very obvious A and B are wrong. Why A and B are wrong? This fraction is less than 1, as you can see. Numerator is less than denominator. This, of course, this value is less than 1. Now alpha and alpha S, this is in our hands. That means question does not specify whether alpha A was more or alpha S was more. We know that even if we choose alpha A more than alpha S, then also the answer will be less than 1. We know that even if we choose alpha S more than alpha A, then also the answer will be less than 1. So whether alpha is more than alpha S or alpha S is more than alpha A, in any case, answer will be less than 1. So if you choose alpha A more than alpha S, then option A becomes greater than 1. So this is not possible. If you choose alpha S more than alpha A, then option B becomes more than 1. So option B is also not possible. Only possibility left is option C and D. So again, out of these 4 options, we have rejected 2 options by absolute surety. Like with absolute surety, we are sure that A and B cannot be right. So out of C and D, you can take a logical guess. I had told you that if you have rejected 2 options with absolute surety, then it makes sense to take a guess out of remaining 2. Anyway, this question is simple. You can do this by proper physics. But in case you are not able to solve this question by proper physics, you take a guess. Right? Let us see this question. A long horizontal rod has a bead which can slide along its length and is initially placed at a distance L from the one end of the rod. So basically this is the axis and this is the rod, and let us say the bead lies here and this distance is L. Okay. It is set into angular motion about it. So basically this is rotating it with angular velocity omega, let us say, and constant acceleration, angular acceleration alpha, not omega. So basically it is rotating with angular acceleration alpha. So this is the value of the angular acceleration. The coefficient of friction between rod and the bead is mu. So coefficient of friction is mu, and the gravity is neglected. Then the time the bead will start slipping. So we have to, what is happening here, you are rotating the rod and you have to find the time after which the bead will start slipping. This is what they are asking. Okay. Now think, if you see option D says that infinitesimally small. That means it says the moment you start rotating, it will start slipping. Does that happen? Think logically. If I put a bead here and I start rotating, so immediately it will not slip. It slips after a while. Okay, like if I start rotating, it will not slip immediately. So option D says infinite, like immediately. So of course option D is wrong. Out of A, B and C. Okay, out of A, B and C, if you think carefully, all the options have got different dimensions. Okay, I think not all the options, but mu is dimensionless. So I think all the options have got same dimensions, not the different dimensions. A, B and C, all the options have same dimensions because mu is a dimensionless quantity. So all the options have same dimensions. So you cannot use dimension analysis. Okay, you cannot use dimensional analysis, but you can use one logic. What is that logic? If mu tends to 0, suppose mu 0, that means there is no friction. If mu is 0, that means no friction. What does this mean? Bead will slide immediately. bead will slide immediately, because if there is no friction, who will stop it from slipping? There is no friction. The moment you start rotating, it will go away. It will not wait. So we can say that in this case, answer should be 0. In this case, the answer should be 0. So if you put mu 0 here, option C becomes infinite. So this is wrong. If you put mu 0 here, option C becomes infinite. This is wrong. Option A and B, they still have the value 0. If you put mu 0 here in the option A, or if you put mu 0 in the option B, then you are getting 0. So A and B are a possibility. So again, we have rejected two options with absolute surety, and now we can, take a guess out of these two, because we have rejected two options with absolute surety. So if you are able to do that, you can definitely take a guess, right? Let us see this question. This is again JEE 1992 question. If you see what is happening here, two identical thin rings, each of radius r, are coaxially placed at distance r apart. So basically, let us say this is one ring and this is another ring. Both are of radius r. Okay, the radius is r. The radius is r. Okay, and placed a distance r apart. They are also distance r apart. So that means this distance is also r. Right? If Q1 and Q2 are the respectively the charges uniformly spread on two rings, that means the charges here, if you assume, so basically this charge is Q1 and this charge is Q2. The work done in moving the charge Q from center of one ring to another, that means initially the charge Q was here and now you are placing the charge Q here. Okay, so think guys carefully. If the charge Q is here, okay, and if I assume Q1 equals to Q2, if I assume Q1 equals to Q2, right? So basically I am saying that this is equal, Q1 and Q2 are equal, right? So in that case, whether you place charge here or whether you place charge here, it is irrelevant, right? Because the situation will be exactly identical. Whether you place a small q here or you place a small q here, both the rings are identical, both have got same charge. So there will be absolutely no change in the energy. I am hoping that you understood what I told you. If you assume Q1 and Q2 are equal, then whether you place a small q on the left ring or the small q on the right ring, where there will be no difference in the situation. So there is no change in the energy. That means work done should be 0. So in that case, we can say that work done should be 0. Right? Understood the logic? Because we can say that whether you place charge on the left ring or on the right ring, small q, whether you place a small q on the left or on the right, absolutely doesn't make any sense, difference, sorry. It makes sense, but it does not make any difference. So we can say that in that case, answer should have come out to be 0, as simple as that. So again, you can see this is wrong, and this says that option A is always 0, which is of course wrong. Option A cannot be always 0, because if the charges were different, then of course the situation would have been different. If Q1 not equals to Q2, then you will have to take the charge and you will have to do some work. So if Q1 equals to Q2, then option C is rejected. If Q1 equals to Q2, this is also rejected, because answer should be 0. So option B is left. Option A, I told you why will you reject option A? Because it is saying in all cases option A will be correct. That means even if capital Q1 not equals to capital Q2, then also it is saying that work done will be 0, which is not, of course, which is not going to happen. So guys, I hope you're understanding the logical way or smart way of solving this question without much physics. Just simple logic, right? So I hope guys you have understood. Let's move to the next question. See this. Two identical charged capacitors have the same capacitance C. One of them is charged to potential difference V1, other is charged to potential difference V2. So that means this is capacitor C. Okay, this is charged to potential difference V1. Okay, and this is charged to potential difference V2. Okay, this is also capacitor C. Okay, now the like plates are connected. That means the positive plate of this and positive plates of this are connected like this. So you have to find the decrease in the potential energy. You have to find the decrease in the potential energy. Think if V1 equals to V2, what happens? If V1 equals to V2, then both the capacitors are identical. If V1 equals to V2, then both the capacitor again becomes identical. Nothing happens, no change. If suppose V1 equals to V2, then you have charged this capacitor to V and you have charged this capacitor to V. There is no change in the energy. So in that case, delta U should be 0. Answer should be 0. So if you check option, I think I have by mistake I have written both of them as minus. One of them was plus. This was the correct option that was given. So one of them was plus, one of them was minus. So again, this will be B, this will be C, this will be D. So you can see that if you put V1 equals to V2, this is not coming out to be 0. This is wrong, not possible. If you put V1 equals to V2, this is not coming out to be 0, not possible. So only possibility left is option A and C. Only possibility left is option A and C. Out of A and C, again, we have absolutely rejected two options B and D. We have rejected B and D with absolute surety. So out of like 4 options, we have rejected 2 with absolute surety. So in that case, you can take a logical guess and you can, choose any of the correct options out of A and C. Okay, 50% chance you will get it right, 50% chance you will get it wrong. But the idea is that if you are able to reject 2 options with absolute surety, it makes sense. It definitely makes sense to take a guess. I told you the logic behind that in the start. Let's see this question. A uniform chain of length L lies on a fixed rough table of coefficient of friction mu. So this is a black color is a fixed rough table of coefficient of friction mu. Okay. A certain fraction eta of the chain hangs as shown. So this fraction of the chain that can hang is eta. So this fraction is eta. So the moment you understand that the fraction eta of the chain that can hang, that means eta should be less than 1, right? What is eta? Eta is the fraction of the chain that can hang, right? That means we can say that it has to, like, it can never be greater than 1. What can be the maximum value of eta? What can be the maximum value of eta? So basically, guys, we know that answer can never be greater than 1. We know that answer can never be greater than 1. So option D is straight away rejected. If you put mu as 1, let us say, if you put mu as 1, so option D is becoming infinite. So this is not possible, definitely, right? Option D is becoming infinite, it's not possible. We know that answer has to be less than 1 in any case, because answer is the fraction. So fraction cannot be greater than 1 because a chain cannot hang more than its length, right? So our answer has to be less than 1. So if you put mu as 1 here, so this is becoming infinite, option D is rejected. Again, if you put, let us say, mu as, let's say 1.5. So this option is also becoming greater than 1. If you put mu as 1.5, check option C, put mu as 1.5. Some students feel that mu cannot be greater than 1. It is not true. Mu can be greater than 1. Okay, mu can be greater than 1. So if you put mu as 1.5, so that means this will become 3 upon 2.5. So this becomes greater than 1. Eta becomes greater than 1. Okay, so of course we knew that eta was less than 1. So option C is becoming greater than 1. Hence it is not allowed. Option C is also not allowed. Right? Now we are left with option A and B. Okay. Again, if you put, I think if you put mu as 1.5 here also, option B is also rejected. I think this straight away logic. If you put mu equals to 1.5 here, so what is happening? This will become 3. Okay, and this will become 0.5. So that means this will become 6, which is also not allowed. So option A is the only possibility which is correct. So guys, I hope you would have understood the rationale behind. I shared some of the techniques with you: dimensional analysis, checking the range. So mu equals to 0, mu equals to infinity, all these things, and answer cannot be greater than this, answer cannot be less than this, positive, negative, these things we have checked for today. I hope you would have understood. I hope you would have realized that there are some smart techniques which helps in solving the question, even if you have just basic knowledge of physics, right? So thank you for today's session, guys. I hope you would appreciate. So that's all for today. Thank you.